All right, in this lesson, I want to revisit a few more of those concepts around the three-tier architecture and see how that architectural approach can inform additional coding that we can do in our application. So first, let's turn back to this diagram and just revisit a couple of ideas in it. The main thing I want to draw your attention to is the fact that in this diagram, I have depicted the service layer or the business logic layer a little thicker than the presentation and data access layers, especially thicker than the presentation layer. And what I was trying to convey here is the idea that you typically want to keep your presentation layer relatively thin and shallow. In terms of code, what that means is you ideally won't be seeing a whole lot of logic implemented in this presentation layer, and you're striving for code in the presentation layer that doesn't do a whole lot, and it really just passes control down to the business logic layer and the data access layers to do most of the work, okay? The presentation layer is fairly thin and not doing a whole lot. That is what you're typically striving for. And so just to recap some of the reasons why you would prefer to keep the presentation layer relatively thin has to do entirely with the clients that are using your application, okay? So what ends up happening is that if you have a lot of code and especially a lot of logic implemented in the presentation layer, that logic probably can't be very well reused across different client technologies. So for example, if a web browser is connecting to our application, which in this case it is, and we've put too much inappropriate logic in the presentation layer, and what I mean by inappropriate is like business logic or data access logic in the presentation layer. And then later on, we decide that in addition to allowing web browsers to be clients of our application, we now want to allow a native smartphone app to access our data. Chances are, whatever we've put into this web layer won't be appropriate for the native mobile client. Okay. But if we could have architected our application in such a way that we could have put the vast majority of our logic down in this lower layer here and kept these presentation layers relatively thin, then we get the opportunity to reuse most of the application regardless of what the client type is, okay? So we're just trying to reuse as much code as we can and have as little duplication of code as possible. I've said this now so many times throughout this course. So much of what good architecture is really about trying to reuse as much logic and code as possible with as little duplication of code as possible. That's a whole lot of what we're always trying to do, okay? And so as long as you can understand that basic idea of reusing code as much as possible without copying and pasting it, you're going to be in good shape, okay? All right, so having said all of that, keep that in mind while we're looking at this code again. Okay, so we're back in the IDE here, and I want to go back into our person controller. And let's analyze this a little bit now. So we've got a few things that I think we can improve on a bit. One thing that we're doing here is that in this save method now, our save method in the controller is now responsible for coordinating both the saving of the file to the file system as well as the saving of the person record to the database, okay? So this controller method is coordinating both of those calls. So now let's consider something. Let's say that we wanted to create a desktop user interface for this same functionality here, and we wanted that desktop interface to be able to reuse as much of our code as possible. First off, our desktop application would not use any of this code in the controller at all, because this controller is here to enable web browsers to be able to interact with our application, okay? That's what the controller is for. That's what this controller is for. So if we wanted to write a desktop application, we would need another class that did a lot of the same things that we're doing here, but it would do it for a desktop application instead of for a web application, okay? So there's a good chance you'd see a fair amount of duplication of ideas, if not actual code. So for example, here where we're coordinating the saving of both the file and the person record, we would have to do that again for our desktop application. And eventually, when we get around to implementing a proper delete functionality, because now we need to delete the uploaded file from the file system as well as the person record, right? So we'd have to do that type of coordination for various CRUD operations now. And so to varying degrees, we'd have to duplicate that type of coordination for each client with the way that we've currently written this, right? And so I would propose that there's a slightly better way to not have as much of that duplication of effort going forward, okay? And this is where we can now introduce this middle service layer or business logic layer, okay? So that's what we're going to do. So where I would typically start is that I would open up this project pane here, and I think we're now ready to introduce another package into the application, okay? And I would typically call this package service, and I would put this under the biz package here, okay? So I'm going to highlight this. Now I know this says biz.model, but that's because the IDE has consolidated the sub package of model under biz because it's the only package that we currently have under biz. But I can highlight this anyway and then do a command N, and then I will say that I want to create a new package, and I will delete the model there and I will add in service. So I will have biz.service. All right, and so now we've got service and model under biz, okay? And now I'm going to introduce an actual service class, okay? And service class is the typical nomenclature we would use for our business logic middle tier classes, okay? So you've got your controllers in the presentation layer. You've got your repositories or DAOs. I mentioned that back in the database section. DAO, data access object. That's just another pattern that's very similar to the repository pattern. It pretty much serves the same purpose, or at least it can. So you've got that. And then in between these two tiers, you've got your service classes, okay? So we're going to create a service class. Now, typically what you'll find is that most Java developers will create these service classes and model them off of the major domain classes that exist within your application. So in our application, we really only have one domain class or concept, and that is person, okay? So let's see what this would look like if we go ahead and create a new Java class, and I will call it person service, and enter. And I will go ahead and allow that to be added, and let's make some room here. Okay, so here we've got our person service. So what we're really gonna aim to do with this person service is to utilize it as the central coordinating class for all things related to a person, right? So where I was just showing a minute ago that we had code in the controller that was coordinating the saving of both a person and that person's photo file, perhaps we could allow this person service to do that coordination instead so that the controller can get a little bit thinner and hopefully a little bit simpler, okay? So we'll see what that will look like. All right, so here we've got our person service class created. And one of the first things you may want to do is to go ahead and register this class with Spring. And so just as we have the @controller annotation for our controllers, and we have the @repository annotation for our repository classes, there is an @service annotation for our service classes, okay? Now let me let you in on a little secret. In actuality, the @controller, @service, and @repository annotations, as well as the @component annotations, those four annotations are essentially really all the same annotation, okay? They don't actually imbue your classes with any special, unique functionality between those four types, okay? The only reason that there are four different words used for those annotations is more so for human consumption, so that a human can look at one of those classes and understand, oh, this is a service class, meaning it will do coordination and business logic type things. This is a controller class. This is a repository class, okay? But really, we could have annotated all of these classes with just @component, and Spring would not care at all, and the application would work just as well, okay? So these different namings that we have here, service, component, controller, etc., these are really just for us. All right, so that's one step that we can take. So since I'm proposing that we're going to allow this class to coordinate between the person repository and the file storage repository, I think we're going to want to have instances of those two classes injected into this class, just as they currently are being injected into our controller now, okay? So let's see what that would look like. By the way, you may often see these fields that we are wanting Spring to inject online and in documentation and things flagged as being final, and that's totally fine, just meaning that once your instance of your service or your controller or whatever gets injected by Spring with these dependencies, that shouldn't change. Totally fine. In fact, it's actually considered to be a good idea. I will admit, I personally don't always have the habit of doing that. I probably should. So I just wanted to mention that. So please forgive me as you see me probably mostly not doing that, but it's not a bad idea to do. All right, so private final, and we will reference the person repository and give it a name like so. All right, and then let's also get a reference to the file storage repository. And I don't know, we'll just call that storage repository for short. And then let's get a constructor. And we will let the IDE generate this constructor, taking as input these two types here. And notice as soon as we generated that constructor, those errors went away on these two fields now. All right, so now we need to basically just re-implement a few of the methods that our controller is currently calling on the person repository, right? So the controller is calling the ability to save a person, for example, right? And basically those standard CRUD operations, right? So let me remind you of a little technique that I taught back in, I think, the object-oriented or advanced object-oriented section, something like that. We can have the IDE generate delegate methods for us. And a delegate method is really just a pass-down method, okay? So in other words, currently the controller is calling person repository.save. Now what we're basically going to try to do is slip an instance of the person service in between the controller and the person repository, okay? But we want that method more or less to look quite similar to the save method of the person repository. And so what we can do is we can tell the IDE to generate some delegate methods based on functionality that exists in fields that are already on this class. And if I said too many words just now, don't worry. Hopefully you'll understand what I mean as soon as I show it to you right now. So what I'm going to do is tell the IDE that I want to generate something, and I can do that with a command N. And what I want to generate are delegate methods. So now the IDE is asking me, okay, you want to generate delegate methods for what field? And I'm going to tell it to generate delegate methods for the person repository, which basically means create pass-through methods for some or all of the methods that are on the person repository class, okay? So next step is to choose which field, and I want the person repository, and then I'm going to click OK. And now I get a chance to choose which of the methods on the person repository I would like to generate delegate methods for, okay? So I don't have to accept all of them. And I think for right now, I won't accept all of them. So I know for sure that I want the save method, and I will likely want the find by ID and the find all and the delete all by ID. And if I need any others, I can go through this process again, okay? So I think that might be enough for right now. Alternatively, I could have selected everything as well, but I don't really want to pollute this class with a lot of unnecessary code that I don't want to be seeing if I don't need it, right? Okay, so I click OK. And so now what I have here is the IDE has generated these delegate methods. And if you notice, they share the same signature as the underlying method of the repository, okay? And then they just turn around and call the underlying method. And again, these are what I often will refer to as simply pass-through methods, but technically they are delegate methods, okay? These methods are delegating down to the underlying repository methods. All right, so now we've got that. So let's re-implement the ability for our controller to save a person, okay? So we know now If we jump back over to the controller, we know that the controller needs to save both the file as well as the person record to the database, right? It's doing both of those things. So how can we delegate all of that down now to our person service? Well, first off, let's go up to the top of the controller here and let's add an instance of the person service now. And notice here, I'm not making these fields final, even though I maybe should, but I will stay consistent over here. Person service, and I will call it person service. Now, to get an instance of that injected, I will need to add another argument to the constructor here. So person service, and then I will need to actually set that. So this dot person service equals person service. There we go. Okay, so now our controller will be injected with the person service as well. Now, eventually we might remove at least one of these, okay? But we're trying not to break too much functionality all at once. Okay, so then we can come down here to our save method and we can implement some alternative code. Let me make this bigger. So I think what we could do alternatively is say something like person service dot save, and we will of course pass in that person, but I think we also are going to want to additionally pass in perhaps this input stream here. So let's see what that might look like. Now we're getting a red squiggly because we don't actually have a method on the person service that allows us to pass in both a person and an input stream currently, but obviously we're going to fix that right now, okay? So I'm putting my cursor right there on the little red squiggly, and then I will do an option return. And the very first option I'm presented is one to add an input stream as a second parameter to the existing save method. And that is exactly what I want to do. So I'm going to click on that. And now my red squiggly goes away. And so then if I put my cursor on the save method here, I could either right click on it to jump into it, or I could have done an option command B to get in there. And so now we see that this method is taking two parameters, an entity and an input stream. I think I'm going to rename this entity to person so that I can have a little more context. Person. Also notice now that the IDE, when it generated these delegate methods, the original method was generic. And so the IDE created this delegate method generically as well. I actually don't think I want that. It's not going to hurt anything necessarily, but I think it's making the code unnecessarily complicated looking. So I'm just going to delete the generic stuff there and the generic return type, and I will just replace that with the actual return type of person. And now having done that, I also need to set this type of S to person as well. And there we go. Okay. All right. So we are now saving the person. Obviously, I don't want to return from this method yet, though, because I still need to also save this input stream. And I'm going to intentionally do something here. I want to save the person first and then the input stream secondly, okay? So what I'm going to do is I'm going to select all of that and I'm going to extract a variable out for that. And I will just call it saved person, okay? All right, so we can return the saved person, that's fine. Honestly, we don't really need this instance. I don't think we would use it in the controller, but this is a common pattern with Spring Data save methods. Okay, so there's that person. So then we want to also be able to save our input stream. I probably should rename this as well. I'm just going to call it photo. All right, so to do that, then I can refer to our storage repository and then call the save method here. Now this method takes two inputs, the file name of the file that we're saving as well as the input stream. So I can get that file name directly from the person, right? Because we have that already on the person instance. So there's that. And then I can pass in the photo. Actually, you know what? Maybe I should name that photo stream or something, photo stream, just to kind of indicate that it's the stream of the photo. Not that it matters a whole lot, but okay. And so now we've got the ability to save both of these sets of data all from this one method. And then if we jump back over to the controller here, so now we should not need those two lines anymore. And the nice thing is that if I were to create another client for this application, like my desktop client, I could now inject the person service class, which has nothing to do with web things at all. And my desktop application could now just use that person service, no matter how it obtains the person object or the photo file. That won't matter. It'll do it in a desktop-centric way, but it can pass it all down to my person service, okay? And that is the main point that I wanted to convey there. Okay, so let's put that back. Let me reload, and I'll open back up the output here. Okay, and then let's refresh the browser window, make sure we are good here. Okay, everything looks like it's still working here. And so let's actually just try creating another record. And let's see here. Let me start with the file there. And I guess we were playing with this Jake Nakos, but we never actually properly uploaded anything using Jake. I don't think we did, at least. I'll go ahead and select that. In fact, let me just check real quick here. I will open up my terminal and just check if I have a Jake Nakos. No, I do not have a Jake Nakos. Okay, cool. All right. So let's create Jake Nakos. And let's give him a birth date of something random. jnack@photos.com with a salary of $35,000. All right, and so let's see what happens here. Okay, so we ran into an issue. System is currently unable to accept photo files at this time. Oh, and I'm so sorry. I think I forgot to show that I actually went back into the run configuration. So let me just show you that real quick. Back up here to run, edit configurations. And yeah, I set that back to be broken again. Sorry about that, because I actually wanted it to be broken and I totally forgot to show you that. So you may want, if you're following along with me, you may want to set that back to something that will make it broken. All right, so I'm going to cancel out of that window there, but there's that error message. But here's the reason I did that. So I'm going to simply refresh now. Okay, I'm not going to try to fix anything. I'm just going to refresh. Look at what happened there. The record for Jake Nakos got created, even though the file could not be written to the file system. So let's look at why that happened. All right, so if we jump back over to the person service, what we'll see here is that the first thing we're doing is trying to save that person record to the database. All right. Then secondly, we try to save the file to the file system. Now we know that this save method here on line 23 is resulting in an exception being thrown, okay? And so that exception is a runtime exception that we're not catching here. And so it's bubbling up to the controller method. So we'll jump back over to the controller. So it's bubbling up to the controller method and it's getting caught. And then we're doing all of this stuff here, okay? But the main point that I want to convey is the fact that this saving of the person record to the database was successful before we had any issue here. Now, perhaps in some cases, that might be totally fine. So what if we don't want things to work in this way? I mean, one thing you maybe could consider doing is just moving the saving of the person to occur after you save the file. And so we try to save the file, that results in an exception being thrown. And in that case, line 23 now would never even be reached. And so that's certainly one way to solve this problem. I would say that it's a little potentially fragile though, because what if we had a lot more logic in this method than just these 2 or 3 lines? You'd be depending on making sure that you and anybody else who touched this code kept everything in just the right order, okay? So that's a little potentially fragile. There's actually a better way though. So I'm gonna put that back. And what we can do instead is this. So back in the database section, we confirmed all of our functionality in that section by writing integration tests using JUnit, right? And you may recall that we were using a combination of the ability to auto-commit data. Well, actually, we were turning off the ability to auto-commit in most cases, but we had this ability to auto-commit our data and tie those commits to transactions, okay? And so basically, underneath the hood of a lot of this code, whenever we're working with a database and saving data into a database, a transaction is getting started and then committed, okay? So we can actually make use of this concept of transactions to change this behavior that we're seeing here. And I want to show you what that would look like real quick. The simplest thing that we could do is actually put a special annotation on this method called transactional. Okay, and so what this is going to do is it's going to tell Spring, which is managing our connection to the database, essentially to start a transaction on this method here. And the nice thing about this is that, yes, this repository will save our person to the database. However, the record that is written to the database will not be committed until this transaction is complete. And the transaction cannot be completed until this whole entire method ends happily, okay? So if an exception gets thrown during any part of this method, this transaction will not commit, and therefore the person that we are trying to save here will not be permanently stored in the database, okay? And all we had to do is just put this @transactional annotation here. So we're going to try this again. All right, so let me reload. All right, and then I'm going to refresh the browser window here. All right, so there's Jake. So I'm going to delete Jake, the record of Jake. I'm going to delete that. All right, and I will even reload again just to prove for sure that Jake is gone. And let's also just take another peek at the file system here. Okay, very good. So still there is no Jake in the file system. All right, so then we'll come over here and we will create Jake again. Jake, Nakos, JNAC, salary of $35,000, and let's pick Jake's photo. There's Jake. All right, and let's save. Okay, so we got that same error again, and now if we refresh, there is no Jake record here, okay? So that's because our attempt to save Jake here did not commit to the database because the exception here caused a transaction. So you can just imagine this transaction as some kind of like safety net around this entire method, okay? And that exception kind of broke that transaction and prevented it from committing any data changes that we tried to make during this method, okay? So this is a very powerful technique that can be utilized to ensure that if anything goes wrong during a service method, that you essentially can roll back or undo whatever was done, particularly to your databases, okay? Now, obviously, you have to be working with technologies that actually participate in transactionality, and databases are probably the most famous type of technology for doing that. But my point here mostly is the fact that by wrapping this method in a transaction, we can essentially undo certain changes that were made, particularly to the database, if any other actions within this method fail to complete successfully because they threw an exception or something like that. All right, so that's enough for this lesson. In the next lesson, we'll probably go ahead and implement the delete functionality using our new person service as well, okay? So I will see you in the next one. Hey guys, thanks so much for watching. If you enjoyed this content and you'd like to help me out, there are several ways you could do that. First, you can always click the like and subscribe. That'll help me out a lot. Additionally, another way you can help me out is to check the link in the description below. That'll link you to my website where you can find additional courses. And finally, for those of you who might be interested in starting a new career as a professional software developer, I offer a free PDF guide that will detail exactly how you can get started in this field with no college degree and no prior experience. All you need to do is click on the link in the description below. Thanks again, and I'll see you in the next one.